N1 vectors, example 2. In an orienteering exercise, we have a cadet who leaves a starting point S. I've done a diagram over here. Starting point S and walks 15 kilometres on a bearing of 120 degrees. Now, this is my north line. Up to the top there, and 120, think about the size of it, 90 degrees would be east, so 120 is just a little bit further than that. So that's 120, and she walks 15 kilometres along there until she reaches A, which is the first checkpoint. I've drawn in another north line here. From A, she walks 9 kilometres on a bearing of 240. Now, if north is upwards, south would be 180, that would be downwards, west would be 270. So all this here, that's approximately the size of 240 degrees. Walking along here for 9 kilometres until they reach a point B, and then they return directly to the starting point. So we've got to describe the displacement of S from B. So we've got to be remembering when it says from B, it means you're standing at B. So where is S in relation to B? So the main thing we need to focus on is this triangle here. It's not right angled. We can work out another few things that are going on. You may remember that if you've got two parallel lines and a line cutting across them, which is called a transversal, these two angles here will add up to 180. They're called allied angles. So this angle here will be 60 degrees. So 120, 60, add up to 180. So they're called allied angles. You do need to be aware of those for this kind of problem. Now, non-right angle triangle, this may be a right angle, but we don't know necessarily, so we can't assume that it is. So we're going to be using the cosine rule. So a squared is b squared plus c squared minus 2bc cos a. That's the standard format. I'll just change pen colours so we can see a bit more clearly the labelling. So I want to know this distance SB, so because that's at the front of the formula, I'll call this side A. It also happens to be opposite the angle A, so that makes sense. B is opposite B, and then what is called S in this one is what we would normally call C in our standard application of the formula. Remember, the side and the angle have to be opposite each other. Okay, so A we don't know, that's what we want to know. B is 15, 15 squared. C is 9, so that's 9 squared. And then this is all one term, remember, 2 times 15 times 9 times cos of, now A, for the purposes of this triangle, is that part there. Full turn is 360. Take off the 240, that leaves 120. Then you have to know that this is 60. So take off another 60, and that leaves us with 60 in there. Now, if you work that out and then take the square root, we should get root 171. Try that on your calculator. And it's 13.1 kilometres if we're doing it to 3SF. So that's the actual distance, but we want the displacement, so we also have to give the angle. Now we know that this part here is 120. We don't know these other two angles inside the triangle. So let's try and work them out and see where we get to. So let's call this one here theta. And remember, with the sine rule, we're looking at pairs. So remember, you can do it either way up, but the standard way that it's written, sine A over A, sine B over B, and sine C over C. You choose any two of those. So given that we know, let's say A, and we know the side length A, they'd be helpful to use. So we'll use A, so it's sine of 60 on the top, and I'll use that full value on the bottom, that's why I kept it root 171. And then the other one, if I want to know theta, then I'm talking about C. So it's sine of theta on the top, and C on the bottom, which is 9. Pause the video, see if you can work out what that angle is. And you should have got 36.6 degrees. Now that tells us this angle here, 36.6, but we want the displacement of S from B. So if you're standing at B here, you've got to work out what all of this angle is here in order to work out the bearing. So if I just change a colour of pen once again, I think I might have to use a black pen now. We're trying to work out this full bearing round here. Now, if I just do a bit of a dotted line coming down here, that would help. This angle here, if that was a straight line going down, would be 180 minus 120 minus the theta that we've just worked out. So this small angle here at the bottom, if you work that out, 180 minus 120 minus theta, that works out to be 23.4. And the reason I've worked that out is because we have here what you might at school have called Z angles. They're actually called alternate angles. And this angle that I've just shaded in black here is the same as this angle, which we need to know here. So working out that one at the bottom, and then because they make a kind of Z shape like that, these are called alternate angles, these two. So this one here at the bottom would be 360 minus the thing we've just worked out, 23.4. And so that whole big red term there would work out to be 337 if we're doing it to three significant figures. So the answer to the question is that S is on a distance of 13.1 kilometres from B on a bearing of 337. So remember, displacement, you have to give an actual length, and you have to also give an angle or a direction.